Welcome back. Problem 12-20. So statement is determine the equation of elastic curve using x1 and x2 coordinates and specify the slope at A and deflection at CEI is constant. So you can see that this is the beam. This is the beam where this there is a point loading at point C and there is a movement of 20 kips. There is a support at B and A. So we will find the equation of elastic curve in term of coordinate x1 which is v1 and in term of coordinate x2 which is v2, and we have to find the slope at point A and deflection at point C. So you can see that due to this loading, so we will having the equation of slope will be like this one. So we will have this slope which is VC, and we have to find the deflection at point A. So let's start with the solution. So first step is that if you remove this support at A, so definitely you will be having a reaction force. Let this is RA, and if you remove this support, so you will have a reaction force which is RB. Now you can see this load is downward, so this will be upward, and in order to keep it balanced, this should be downward. So you apply the first equilibrium condition is that sum of all movement about point A is equal to 0 and taking the counterclockwise movement as positive. So about point A, one movement is RB into perpendicular distance is 20 feet. That is counterclockwise, so it will be positive. The second movement is due to 8 into total perpendicular distance is 30, and this is clockwise, so it will be negative, and we have a 20 kips into feet movement that is clockwise, that is also negative. So I will write 20 into RB minus 8 into 30 minus 20 is equal to 0. I will repeat RB into 20, that is counterclockwise, plus 8 into total distance is 30, and that is clockwise, and this clockwise, this sum is equal to 0. So when you solve this, you will get RB is equal to 13 kips. Now we will apply another equilibrium condition that sum of all forces along y direction must be equal to 0 and force upward taken as positive. So again you can see that we have RA which is downward. So RA is minus RA plus RB is 13 minus 8 is equal to 0. So from here you will get RA is equal to 5 kips. Now you have both these forces, so we will move to find the equation of moment, because we know that the equation for deriving the slope and deflection equation is dv square over dx square is equal to moment mx. So for x1 coordinate, I will cut the beam over here. So when you cut the beam over here, so definitely you will be having this RA which is 5 kips, and let this distance is x1 because coordinate, and when you cut it you will having a shear force Vx, and you will have a moment m1 of x. Let this is your point 1. Now we will apply equilibrium condition that sum of all moment about point 1 is equal to 0 and taking the upward moment as positive. So first moment is 5 into x1, and that is counterclockwise, so it will be positive, and the second moment is m1x which is reaction moment, and that will be also positive. So 5x1 plus m1 of x equal to 0. So it means that your first moment m1 of x is equal to minus 5x1, and the unit will be in kips into feet. So this is the equation of moment for coordinate x1. Now we will derive for x2. So if you cut the beam over here and draw the free body diagram, so it will be like that. You have 8 kips, you have a moment of 20 kips into feet, and this distance is x2. When you cut it, you will be having a shear force which is V of x, and you will have a moment which is m2 of x. So we will apply neither equilibrium condition, that sum of all moment about point 2 is equal to 0, and taking the counterclockwise moment as positive. So about this point we have external moment m2 which is clockwise, so it will be negative. 8 into x2 is also a negative moment, and minus 20 kips into feet, their sum must be equal to 0. So minus m2 of x minus 8 into x2 minus 20 is equal to 0. So from here you will get m2 of x is equal to minus 8x2 minus 20, and the unit will be in kips into feet. So this is the moment equation for coordinate x2. Now we will apply this equation in order to find the slope. So for x1 coordinate, I will write it EI into dv1 square over dx1 square is equal to m1 of x, which is minus 5 into x1. So if you integrate it, you will get EI into dv1 over dx1 will be equal to minus 5x1 square over 2 plus c1. Again, if you integrate this equation, so you will be having okay, so before going to that, if you divide EI on both sides, so you will get dv1 over dx1 will be equal to 1 over EI into minus 5x1 square over 2 plus c1. Let this is your equation number 1. Now integrate this equation number 1, you will get v1 is equal to 1 over EI, and we will having minus 5x1 cube over 6 plus c1 into x1 plus c2. Let this is equation number 2. So equation 1 is the equation of slope for x1 coordinate, while equation 2 is the equation of deflection for x1 coordinate. Now we will apply the same for coordinate x2. So I will draw a line in order to differentiate. So you will have EI into d square v2 over dx square x2 square will be equal to m2x, which is minus 8x2 minus 20. So if you integrate it, you will get EI into dv2 over dx2 will be equal to minus 8x2 square over 2 minus 20 into x2. So if you simplify and divide EI on both sides, so you will get dv2 over dx2 is equal to 1 over EI, and we will be having minus 4x2 square minus 20x2. Okay. Plus, sorry. Oh, yes, we have this dv2 over dx2. Okay, so when here you integrate it, you will get minus 20 plus c3 as well. Okay, so plus c3. So let this is your equation number 3. Now again integrate equation number 3, so you will get v2 is equal to 1 over EI, and we will have minus 4x2 cube over 3 minus 20x2 square over 2 plus C3x2 plus C4. So if you further simplify it, you will get V2 is equal to 1 over EI into minus 4x2 cube over 3 minus 10x2 square plus C3 x2 plus C4. Let this is equation number 4. Now equation 3 and equation 4 are this equation 3 is for slope for x2 coordinate, and this equation number 4 is deflection for coordinate x2. You can see we have four unknown, that is c1, c2, c3 and c4. They are unknown constant of integration, so we will find them by using boundary condition. So I will write boundary conditions. So first boundary condition is that at x1 is equal to 0, we have v1 is equal to 0. So put it in which equation? Equation number 2, because equation number 2 is about v1. I will also show you the condition. You can see that at here x1 is equal to 0, we have v1 is equal to 0 because there is a support. So when you put this x1 is equal to 0, so this term will be 0, this term will be 0, this term will be 0, and we will left with c2 is equal to 0. Now we will put another boundary condition is that at x1 is equal to 20 feet, you can see v1 is equal to 0, and also put it in equation 2. So let me show you. You can see here at point B x1 is 20 feet, and here you have v1 is equal to 0 because there is a support. So when you put it in equation number 2, so v1 will be 0, x will be replaced with 20 feet. So I will write it 0 is equal to 1 over EI into minus 5 into 20 cube divide by 6 plus C1 into 20 plus C2, which is 0. So when you simplify it, you will get C1 is equal to 333.33, and the unit will be equal to kips into feet square. This is the value of C1. Now we will apply the third boundary condition for x2. So at x2 is equal to 10 feet, we have v2 is equal to 0. So put it in equation 4. So this is equation 4 for deflection due to coordinate x2. So again you can see here that this is the point where x is equal to x2 is 10 feet. So here v2 is equal to 0 because there is a support. Okay. So when you put it in this equation, v2 will be equal to 0. I will write it over here. v2 is equal to 0. So 0 is equal to 1 over e into I, and we will have minus 4 into x2 is 10. So 10 cube divided by 3 minus 10 into 10 square plus c3 into 10. C3 into 10 C3 into 10 plus C4. So when you solve it, you will get 10 C3 plus C4 is equal to 2333.3. Let this is equation number 5. Now we will put the last boundary condition. And what is the last boundary condition? So we will use continuity equation or continuity condition. And what is continuity condition? So you can see that x1 is equal to 20 feet or x2 is equal to 10 feet. At both are the same point. So we have dv1 over dx1 is equal to minus dv2 over dx2. It means slope 1 is equal to slope 2, that is minus. So I have already explained it in previous problem. So this is the point here. Theta 1 is equal to minus theta 2 because theta 1 is taken from x1 coordinate and theta 2 is taken from x2 coordinate. So put x1 is equal to 20 in equation number, which one? Equation 1, because you can see equation 1 is for slope and equation 3 is also for slope but for coordinate 2. So put x1 is 20 feet in equation 1 and put x2 is equal to 10 feet in equation 3 and use dv1 is equal to dx1 is minus dv2 over dx2. So I will just put the value dv1 over dx1 will be equal to minus 5 by 2 x1, which is 20 square. This is the formula I will show you. Minus 5 x1 square over 2. We have 1 over ei with both sides, which will cut later, plus c1, and c1 is 333. This is dv1 over dx1 is equal to 1 over ei. Now dv2 over dx2, this is the formula. So you have to put the value of c3 as well. Okay. So when you put x is equal to 10 in that equation number 3, so you will get minus 4, and you have minus from this minus is always there, minus 4 into 10 square minus 2 into 10 plus c3. So 1 over ei, 1 over ei will cancel and we will get c3 is equal to 1266.67 kibs into feet square. Now you have value of c3. Put c3 in equation 5. I will show you. This is the equation 5. This is the equation 5. So when you put c3 in equation 5, you will get c4 is equal to minus 10333.3 kibs into feet cube. Okay, now we have c1, c2 and c3. So what we will do is that put c1 in equation 1. This is the equation 1, which is slope for, which is equation of slope due to coordinate x1. So when you put c1, so you will get dv1 over dx1 is equal to 1 over ei minus 5x1 square over 2 plus 333.3, and the unit will be kibs into feet square. Now we have given to find theta a slope at point A. So it means that x1 is equal to 0. So at x1 is equal to 0, we have theta a. We will find this, which is the second part. So we'll first solve that. You can solve part first. That's your choice. So you can put theta a is equal to 0 at x1 is equal to 0. So that dv1 over dx1 if you replace x1 is equal to 0 in here. So you can see that this term will be 0 and we will left with 333 divided by EI, and unit will be kips into feet. This is theta A, slope at point A. So this is the answer of our second part. Now we will move toward finding V1 and V2. So put C1 and C2 in equation number 2 and C3 and C4 in equation 4. When you put C1 and C2 in equation number 1, equation number 1 is 2 is this one. So you will get V1, and V1 will be equal to 1 over EI into minus 5 by 6 x1 cube plus 333 x1. Unit will be kips into feet cubic feet. Okay. And when you put C3 and C4 in equation 4, you will get V2 is equal to 1 over EI into minus 4 over 3 x2 cube minus 10 x2 square plus 1 2 6 7 x2 minus 10 3 3 3 kips into cubic feet. Now we have also been asked to find deflection at point C. So it means that this will be the deflection. So deflection at point C is VC. So at x is equal to 0, x2 is equal to 0, we will put it in V2. So at x2 is equal to 0, so V2 is equal to VC. Clear? So if you put x2 is equal to 0, so this term will be 0, this term will be 0, and we will left with minus VC will be equal to minus 10,333 divided by EI. And since this value is downward, so VC, if we write it 10,333 over EI, so I have removed minus and replace it with the downward arrow. So this will be the deflection at point C. And this was all about problem 12.20. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and press the bell icon so that you can get notification about my latest video. If you have any question, you can ask me in comment section. Thank you for watching.